And for number 6, the equation of a curve is 2x squared minus kxy plus 2 equals 0. And the equation of a line is y equals px plus 3, where k and p are constants. A, given that k equals 2 and p is 11, find the coordinates of the points of intersection of the curve and the line. Right? So let's first substitute 2 and 11 for k and p respectively. That will give us 2x squared minus 2xy plus 2 equals 0 for this one. And for the line, we'll get y equals 11x plus 3. Right? And to get the points of intersection, we equate the two, right? In other words, y equals y, right? So we are going to substitute this y in the first equation with 11x plus 3, right? So 2x squared minus 2x, in place of y we put 11x plus 3 plus 2 equals 0. So 2x squared minus 22x squared minus 6x plus 2 equals 0. So this will give us minus 20x squared minus 6x plus 2 equals 0. And for us to get the 2x values, we're going to use the quadratic formula. And that will be 6 plus or minus root of 6 squared, which is 36, minus 4, our a minus 20, and our c, which is 2, all over 2a, 2 minus 20, right? And this gives us x equals minus half or a fifth, right? So we're going to substitute these values into either of these equations, but most preferably this one. So we'll be using y equals 11x plus 3, right? Substituting minus half, we get y to be minus 2 and half, and substituting a fifth, we get our y to be 26 over 5. So the coordinates will be half minus 2 and half and a fifth and 26 over 5. Right? And for part B, we're told, given instead that p equals 4, find the set of values of k for which the curve and the line do not intersect. Right? So if p is 4, this will be y equals 4x plus 3. Right? Y equals 4x plus 3. Right? And the first equation will still be 2x squared minus kxy plus 2 equals 0, right? And we're going to substitute this for y, right? So 2x squared minus kx, and for y we put 4x plus 3, then plus 2 should give us 0. So 2x squared minus 4kx minus 3k, this is 4kx squared minus 3kx plus 2 is equal to 0, right? Then factoring out x squared, we get 2 minus 4k, right, minus 3kx plus 2 equals 0, right? And we're told in the question that we are supposed to find the set of values of k for which the curve and the line do not intersect, right? And for that case, our discriminant, which is b squared minus 4ac, should be less than 0, right? So our b minus 3k squared minus 4, our a is 2 minus 4k, and our c is 2, should be less than 0, right? But we're just going to use an equal sign so that we get the critical points or the critical values. So this would be 9k squared, right? Then this is minus 8 times 2 minus 16. Then this times this, that's minus 8 times 4, that's plus 32k, should be equal to 0, right? Then using our quadratic formula, k will be minus 32 plus or minus 32 squared minus 4 our a and our c minus 16 all over 2a to 9, right? And this will give us k to be 4 over 9 or minus 4, right? So let's try and sketch this, right? So this is something like this, minus 4 and 4 over 9, right? And because the coefficient of k squared here is positive, we know the graph will look like this, right? And because we have a less than sign here, it means we're considering this region which is below the x-axis, right? And we can see that we have that region from minus 4 through to 4 over 9, right? And that will be the region or the set of values of k for which the curve and the line do not intersect.